All right, welcome back. Dr. P here, and in this lecture we're going to look at E1 reactions. So the E1 reaction is kind of like the SN1 reaction if the E2 reaction is like the SN2 reaction. Our E1 reaction will be first order, and it will be unimolecular. That is, the rate determining step is going to be loss of the leaving group. So, for example, we could have this guy here. We'll go ahead and treat this with a weak base. Often it will be a solvent, and heat it up, and we'll end up with that product. So what does the mechanism look like? Well, let's go ahead and take a look here. I'm going to go ahead and show my hydrogens here because they're going to be important later on. My rate determining step is, of course, loss of the leaving group. And that gives me now a carbocation. Now I can have my ETOH here come in, and that can pull off a proton. So with SN1 it added to the carbocation, but here we're going to pull off a proton, and that now gives us our final product, which is the alkene. Now notice this looks like it has the same intermediate actually as the SN1 reaction. So we have our carbocation intermediate. So this looks like the SN1 reaction and competes with the SN1 reaction. So some things to note here about the E1 reaction, in addition to it being first order and unimolecular, we need a good, let's see here, other characteristics. So we need a good leaving group. We do not need a good base. A solvent that is polar protic can be helpful. So protic solvent, helpful. So weak base, ETOH, ethanol, weak base, and a protic solvent. We can get rearrangements. And then lastly, down at the bottom here, heat, which would be our delta up here, is going to favor E1. When we compare it to SN1. So we can actually take a look at the different factors that affect whether we get E1 versus SN1, and ultimately E2 versus SN2, and SN1 versus SN2, etc., etc. So I know this is a pretty short video here, because the E1 is really, It's fairly simple in terms of it has the same requirements as SN1. Reaction starts out the same, loss of leaving group, but then we get a deprotonation instead of nucleophilic attack. So I think it's best if I do some examples in a future video, or maybe I'll do an online office hour / workshop. So I think I'll record one more video for this chapter, and that will be, I'm going to go over the those PDFs that I posted of sort of how you figure out sort of the chart to figure out what's E1 versus SN1, E2 versus SN2, etc. So until next time, stay safe out there. Bye now.